Hi guys, welcome to this video. We're going to be talking about some special cases of integration by parts. So we'll talk about some special cases, and this is part one of that video. So these are the three questions which we will be doing in a sequential stepwise manner, and we'll see what's so special about these and how to tackle these questions. So let's jump into it. We're going to be taking the first question, which is the integration of natural log of x. So let me just add up a new page over here, and let's just start working on this question. So we have the integration of natural log of x. Now, this is really easy. Let me actually pull this up over here. Now, this would have been really easy if we were dealing with, derivative of natural log of x. So we often get confused that, hey, this should be 1 over x, right? But no, please remember, we are talking about antiderivative in this case, not the derivative. So just for the record, I'm writing that d over dx of natural log of x is 1 over x, but the integral is not the very same. Okay, and why is this special? Is because if I intend to solve this question with integration by parts, don't you think that there is no other part? Because integration by parts takes into account two functions which are multiplied together, but there is no other function over here. But remember that even if there is no other function, there is always another function, and that function is 1. Can I write it like this? Can I write it like natural log of x times 1 times dx? I think I can, because it doesn't change the question. And now this gets converted into integration by parts, because there is natural log of x as one function and 1 as the other function. Okay, now we ask ourselves that which one is fx and which one is g prime of x, right? This is where we look for the ILATE rule. So the ILATE rule suggests I-L-A-T-E. ILATE rule gives us an idea about which function do we have to take first, and which one is fx and which one is gx. I stands for inverse, L stands for logs, A is arithmetic, T is trigonometry, and E is exponential. Now, you might be wondering, 1 falls in which category? So 1 is nothing but x raised to 0, right? And x raised to 0 is nothing but arithmetic. So in this question, we are dealing with natural log of x, which is log, which is over here, and arithmetic, which is definitely over here. So log comes above the arithmetic, so the log will be considered as f of x, and 1 will be considered as g prime of x. Right. Let's recall the formula for the integration by parts. So integration by parts suggests that this is equal to fx remains as it is, then we write gx minus the integral of f prime x gx, and here we have dx. So that's what I'm going to do. First, I will write f of x. So what is f of x? It's just natural log of x. So I write natural log of x over here. What is gx? So gx is nothing but the antiderivative of g prime x, right? And what is g prime x? G prime x is 1. And what is the antiderivative of 1? What do we get if we integrate 1? We get x. So we write x over here, which is in multiplication, minus integration of, what is f prime of x? What is the derivative of natural log? It's here. It's 1 over x. So we write 1 over x over here. What is g of x? G of x we just wrote, right? That's x. And this is once again dx. All right, so x ln x remains as it is. And what is x? 1 over x times x. I believe that's just cancelled, and we are left with 1. And what is the integration of 1? The integration of 1 is just x. So the answer is x natural log of x minus x plus the constant of integral is, of course, c, because we don't have to forget that there will always be a constant of integral. So this is the required answer, x natural log of x minus x plus c. I hope the first special case makes sense. All right, what was the second question? Second question was e raised to x sine x dx. So let's talk about that. E raised to x sine x dx. Okay. So at the moment, it doesn't look like a special case, right? Because I don't really see anything special about it, because there's just an exponent and there's a trigonometric function over here. So everything is okay. Everything works pretty well. We go once again to our ILATE rule. So ILATE. We have an trigonometric function with which is over here, and an exponential function which is over here. So obviously the trigonometric function is coming on the top, so it should be the fx. So let me just rewrite this function as sine x times e raised to x dx, because it makes it quite easy, because the first one we have a habit of putting it as fx. So let's put this as fx, and this is g prime of x. Okay, so once again, I will help you by rewriting the formula for the integration by integration of parts. So that's fx times gx minus integration of f prime x gx dx. So let's plug it in the values. What is fx? That's just sine x. So let me just actually go ahead and change the color over here. That's fx, that's sine x. And what is gx? So remember that gx is the antiderivative of g prime x, and g prime x is e raised to x. So what is the antiderivative of e raised to x? E raised to x is a really special function, right? Its derivative is also e raised to x, and its antiderivative is also e raised to x. So here we write e raised to x minus integration of f prime of x. What is the derivative of sine? That's cos. So we write cos over here, and gx is once again e raised to x and then dx. Interesting. We are again left with the product of a trigonometric and an exponential function, something which is of this family. So obviously it makes sense when we apply the integration by parts once again. So this is the fx and this is g prime of x. So let's do another round of it. So that's going to look like e raised to x sine x minus, I'm going to place a big bracket over here so that, just to make sure that this minus is outside everything. Okay, so let's recall this formula and let's write everything. So fx remains as it is, and gx, what is the integration of e raised to x? It's e raised to x minus integration of f prime x. What is the derivative of cos? Be careful, that's minus sine. And what is the integration of e raised to x? That's e raised to x, and there we have a dx over here. All right, okay, so this becomes e raised to x sine x. Now I'm gonna just open up the bracket so this minus gets into both these terms. This will become minus of e raised to x cos of x, and minus, minus, and minus. Three negatives will become negative. So minus integration of sine x e raised to x dx. Well, once again, that's a product of trigonometry and exponential. So don't you think we are stuck in a rabbit hole? This is again and again turning into the same, because we again do this, it will again become cosine. So we have to find a way to get out of this so-called whirlpool. And okay, so that's when we notice carefully, what is this? Don't you think this is our question? I mean, the order doesn't really matter, right? E raised to x sine x dx or sine x e raised to x dx, that's both one and the same thing. So that's our question. And the procedure now to get out of this and to find our answer is to, let's say, consider our question as I. So let's say our question is I. So this becomes I is equal to I is equal to I is equal to I is equal to, and don't you think that now I can replace this guy with an I as well? Right? So if I can do that, I'm gonna just add another page over here. So that becomes equal to I is equal to e raised to x sin x minus e raised to x sin x minus e raised to x cos x minus I. I'll just go back and let you absorb this. I is equal to e raised to x sin x minus e raised to x cos x minus I, because this is also I over here, and that's exactly what I wrote on the next page. So all we have to do is rearrange I, adding I both the sides. It will become 2I is equal to e raised to x sin x minus e raised to x cos x, and dividing both sides with 2, of course, we have the value of I as e raised to x sin x minus e raised to x cos x over 2, and obviously e raised to x is a common factor, so that's going to come out e raised to x sin x minus cos x over 2, e raised to x sin x minus cos x over 2, and obviously there will be a constant of integral c over here. So this is the final answer. So again, this was a special case. We learned that how we were going once again and again into that rabbit hole, and to get out of that rabbit hole, we have to, do the special trick. I hope it makes sense. Finally, our last question is question number 3, which is cos of natural log of x dx. So let's see how we can solve that particular question. So it's cos of ln x dx. Okay. Now, just with first glance, first off, I want to make this clear because lots of students think this otherwise. They think that this is cos x times ln x. No, it's a composite function where the ln is, or natural log of x, is inside the cosine. So basically, it's cos of natural log of x. And sometimes it feels like we can solve it using substitution, but well, not really. We cannot really solve this using a substitution. However, we have to use a u-substitution first, and then we have to use the integration by parts. Because using the natural log of x over here doesn't really help us too much. We are not getting a way out of it. So what we can do is, let's try to put natural log of x as u. So I'm going to go with u-substitution right now. So if you can help me by taking anti-log both the sides, I think it will become x is equal to e raised to u, right? And obviously, if I want to make a u substitution, I need dx as well. So I'm going to differentiate both the sides and make this dx as, and the derivative of e raised to u is just e raised to u du. All right, excellent. So let's plug in everything over here and convert our complete question in terms of u. So this becomes cos of natural log of x is u, so u, and dx is e raised to u du. Okay, excellent. And don't you think that this can further be written as cos u, dropping the parentheses, e raised to u du, and this is exactly question number 2, right? The rabbit hole question. We very well know how to do this question. Just assume this as I and do the integration by parts. So I know I have already explained this, what is fx and what is g prime of x. So I'm just going to go, if you still have confusion, please rewind back and go to question number 2. I've explained which one is fx and which one is g prime of x. So I'm just writing here that this is fx and this is g prime of x. I hope it will make sense if you have gone through question number 2 already. So this becomes cos u remains as it is, and then gx is just e raised to u. I mean, yeah, it should not be ideally be gx because that's a function of u. So let's make it u over here. So I'll just make it 1 second. There's some issue with the So I'm just gonna make it f of u and g prime of u. So now it's gonna look like fx times g, fu times g of u minus integration of derivative of f, so that's negative sign, and then we have integration of e raised to u is e raised to u, and then we have du. So this becomes I is equal to e raised to u cos u, minus and minus is plus, so plus sine u e raised to u du. And once again, obviously, just this is f of u and this is g prime of u. So this is going to look like I is equal to e raised to u cos u plus integration by parts once again. So sine u, it means that f of u times g of u is e raised to u, minus integration of f prime u is cos u, gu, which is e raised to u, and again du. And we very well know that this is our question, and hence this is our question as well. So all we have to do is replace this guy with an I as well. So let's do that. Since the outside sign is positive, so we don't have to worry about it. So let me add the next page over here. So it will look like I is equal to, okay, so that's e raised to u, sorry, keep on forgetting, cos u. E raised to u cos u plus e raised to u sine u minus I, and all we have to do is add I both the sides and take e raised to u as a common factor as well. So e raised to u cos u plus sine u, and dividing both sides with 2 we get I as half of e raised to u sine u plus cos u, and obviously plus constant of integral c. But please do not leave your answer like this. This is not our final answer because this original variable is x, and x is nothing but e raised to u. So I'm going to resub in x, I'm going to resub in u rather as natural log of x, because u should be replaced in terms of x. So u is natural log of x, which means that I'm going to replace every u with natural log of x. So e raised to u is nothing but x, right? E raised to u is x. So I'm going to replace this e raised to u with x, and now the u's are going to be replaced with natural log of x. So this becomes x times, 1 over 2x times sine of natural log of x plus cos of natural log of x plus c. I'm going to box it up, and this is our final answer. Thank you.